Right, so this module is about a very important topic when it comes to dealing with functions, designing functions, and working with functions in a variety of contexts. And that is principally the difference between pass by reference and pass by value. And we haven't really talked about pass by value yet, but we've already used it. It's in fact the only way that we've passed variables as parameters. So we're going to define that in a little bit more detail and then highlight the differences between pass by reference. So this subject is covered in 6.12 or 6.12 in the text. All right, so background. We already know that every variable has a scope. The scope is the amount of time or the period of time or the lines of code during runtime that a variable is active and a variable still exists in memory and can be used. A local variable is defined within a segment of code, such as a function, a loop, or an if statement, of course characterized by those squiggly brackets or the curly braces. Local variables, again, are only visible within the segment they are defined and the subsegments. So we hopefully have mastered that concept so far. Now, of course, if we have multiple functions, we can have each one of those functions containing their own local variables. And in fact, we know that their local variable names can conflict. One function can have a variable named x, and another function can have a local variable named x, and it doesn't cause any problems, and there is no relationship between those two variables whatsoever. So every local variable that's created is completely separate from every other local variable. Now, if you want to access variables from multiple functions, really so far the only way we could actually do that would be through what's called a global variable. And we haven't spent a lot of time talking about global variables, but we can actually, and if you've done this through experimentation or sort of just by accident, you can actually declare a variable outside of all the other functions. This makes it visible to all functions, and it can be used in any of the functions. That's really, really bad design. And we're not going to get into it right now in terms of all the reasons why we shouldn't use global variables. Suffice to say, it will cause many problems in terms of your code will be more error prone, but also some technical problems where variable names will start to conflict with each other. So we stay away generally from global variables, the only exception being constants. So if I have a program that has 6 different functions in it and they all use pi, I probably don't want to make pi defined as a constant in each and every one of those functions. That would sort of defeat the purpose of having a constant in the first place. The idea of having a constant is that we don't need to repeat the value. So that in that case, I might define const double pi outside of all functions and such that it would be visible everywhere. But this idea of variable scope is very important. Now, we've mentioned this briefly, but we haven't really kind of thought too carefully about it. But parameters are also local variables. They are exactly the same as a regular local variable, with the difference that is that they are automatically initialized. So when we declare, and this is just a prototype, but when we declare a function called do this that accepts a parameter int x, this int x is as good as a normal local variable that might be defined within the function. It's the same idea. Its scope is limited to that function. The word or the letter x means the variable that is defined within this function and not any other function that might have variables called x. We should never forget that they are local. And in fact, they are copies of the parameters that are being called with it. So the difference, as I mentioned, they're initialized. When we call do this with 5 here, 5 is copied into x, and then x contains 5. If this was y, if I called do this maybe from main, and I passed in a value y, it's not that I'm actually passing the variable in, but I'm copying the value that's in y and putting it into x. There's 2 variables here. That's why sometimes pass by value, and this is pass by value, we're passing the value in that variable or the literal value is also called pass by copy, right? Because we're literally making a copy of that value, putting it into the parameter, using it within the function, and then destroying it when the function returns, along with any changes that have been made. It's critical that we understand that visually. We kind of get a real appreciation for how this is working. So this little red dot next to the lines sort of represents, maybe like a breakpoint, or where we are in the code. And as we step through, you can see that main starts off with an integer called n, and it's equal to 5. When I call print squared, notice as I call this and I navigate into this print squared function, I'm visually depicting the fact that I now have a new variable called x, totally separate than n, right? And the value 5 has been copied. The value 5 that was in n has been copied into x. Now when I enter into this function and I execute the first line of code, the first thing this function does is it squares x. It says x is equal to x times x. X times equals x. Note that that changes x. It does not change n. Right? We still have that same local variable in main, and in fact we can't even access n within print squared. It's not available to us. It's defined in main. So we've gone ahead and we've changed this x variable. We print it out, and then when we return back to main, that x variable is destroyed. The changes that we made to that x variable are no longer there. And if I had called this n, of course, it just would have been named n down here. It wouldn't have changed anything at all. So when we use pass by value or pass by copy, one of the things that we need to recognize, or one of the limitations of that, and you might call it a limitation, it might actually be a benefit in a lot of cases, is that any changes that you make to that parameter variable inside the function, any changes that you make to x inside this function, are completely hidden from anywhere else in your program. It's as if it never existed. When you return from this function, those variables are gone, and that change that you made to x is no longer relevant at all. Now there are times where we would like that to be relevant, where we would like to pass in a variable n, and if this variable was changed down here, those changes were somehow reflected in the variable we passed in the first place. But that represents a very different type of parameter passing. It's not passed by copy, it's not passed by value. What it's called is passed by reference. Now passed by reference, it's amazing how different this program is just with one small character change. Pass by reference fundamentally alters the way functions work completely. However, the only thing that gets added here is that ampersand. Notice that we call print squared exactly the same way as we did before. And if we go back to the previous slide, it's exactly the same print squared function, look right here, as before. However, when we declare print squared down on this slide, we've put an ampersand between the data type and the variable. What this is now saying is that when you call print squared and you pass a value, we do not want print squared to make a copy of that value. We actually are passing in a reference. Really, we're passing an address of this variable. So we're going to call this variable x down here in this function. But when we say x, we're really talking about the same exact piece of memory that n is using. So as I call print x, or print squared, the x value is really not a separate variable. It's actually just an alias. Any changes that I make to x are actually taking place on n. When I return, I still have those changes, right? And I still have that 25. By the way, when we use pass by reference, one thing that we can't do is we can't call print squared 5 or print squared 10 because pass by reference require you to pass in a variable, not just an expression, not just a value. And that's a pretty important distinction. So why would we want to use this? What's the purpose of having pass by reference? It turns out there's a couple of little guidelines to use. First of all, now that we've learned pass by reference, it does not mean we should use pass by reference all the time. Pass by reference actually can be very confusing. And as we start to design some programs using it, you'll see that this whole concept of actually passing references or addresses can lead to a lot of bugs. So it's not something that we want to use all the time. There's a reason C++ didn't make it the default way, and that's because it's easier to write correct programs using pass by value and pass by copy. However, it is necessary every once in a while. Prime examples for when it's necessary is if I need an input variable to change within a function and have that change available after the function is called. Right? So when in shorter terms here, when I pass a value to a function, if I want that value to actually be modified by that function, I might use pass by reference. Now that doesn't mean all the time. Right? So I could have gone back, if we go back here, print squared modifies the variable and it prints it out. I could have easily changed this code though to print the squared value and return it. And if I was to return that, I could have used this pass by copy and just simply returned x and then stored x into n, said n equals print squared. That would have affected the same exact change to n. Right? So in that case, we would not have actually required pass by reference just because we wanted to change the parameters. However, the second sort of argument here kind of comes into play with that line of thought. We can't have a function return two pieces of data, at least not yet. If you go on and you learn about object-oriented programming, you can kind of have a function return multiple values using those strategies. But right now, we can't ever have a function return two things at once. It can only return one thing. There's lots of times where we want functions to actually return two things. You call a function, and there's actually two answers or two resulting changes. And if we have that situation, we really have no other option but to use pass by reference, so parts of the things that are changing can be used or passed in by reference. Now the third reason, and we'll talk about this a little later in some future modules, would be to use pass by reference to avoid the overhead, the computational and the memory overhead of making a copy. We'll deal with that when we cover arrays. We're not going to really worry about that right now. So I want to give you an example of a situation where that falls into this second example, and kind of by definition also falls into the first one. And I'm starting with a programming example that we did very early on. So programming example 27 is asking us to compute change. Between 1 and 99 will calculate the most efficient coin usage. And if you recall, we actually did this. This is program example 5, in fact. We used the modulus operator and integer division to compute how many quarters, dimes, nickels, and pennies went into some change. Now the only difference here is that I'm going to use functions instead. So let me bring up Visual Studio and just walk us through program example 5 as a bit of a refresher. So in this example, the user was entering in some dollars and cents. If you go back to the video for module 5, there's a discussion about the casting and how to get this into a correct format of an integer. We'll leave that alone for now. We'll assume that we remember what that was all about. Here's the bulk of the work, though. Right? So we had a variable Q for quarters, D for dimes, N for nickel. And for each one of the denominations, we do an integer division of the current amount of change by the denomination, 25 cents. That gives us how many quarters? So 86, if the user typed in 86, 86 divided by 25 would give us 3, an integer division value. We then needed to update the amount, so we had the amount left. So 86 mod 25 would give us the remainder, of 11. It's the integer division remainder of dividing it by 25. And if you look at this now, each one of those steps, all 3 of those steps, they are doing the exact same thing, other than, of course, they're storing a result in a different variable, and their denomination is different. So if I wanted to kind of use what now I now know about functions, I could say something like this: compute coin int amount int denomination I can write my function, and I could do this exact thing. I would say maybe int value equals amount divided by 10. I could change amount, and I could return value. And then instead of duplicating this code, and it's not that much duplication, I could just call compute coin with amount and 25. And the same thing for D, but with 10. And the same thing with N, but with 5. So you can make the argument that's not saving all that much code, but it's kind of a nice idea. And if we had more denominations, certainly it would be more valuable to have a function like that. So when I call compute coin, I pass in the total amount, maybe 86, if the user types 86 in the denomination. We're going to come up with the amount, we're going to change the amount, and return the value. Now if we run this, though, it's not going to work the way it used to. So I'm going to run the code. I'll use my test example of 86. And I get 860 quarters. That doesn't look right. I did something wrong there. So let's fix that first. And I'm just looking at this, and I used, instead of the denomination, actually I used wrong value. So that should have been denomination there. I think if I look back at this now, thinking a little bit more carefully, I actually did this static cast so I could type in like $1.86, 1.86. So I shouldn't have typed in 86, I should have typed in 0.86. Now when I do 0.86, I get the 3/4, and that's what I would have thought I should have gotten, so we can ignore that part of it. But I get 8 dimes. And I get 17 nickels and 86 pennies. This is way more than 86 cents. This isn't right? And the problem, and if I had run this before, what I should have seen was one dime, 0 nickels, and a few pennies, right? So I'm not seeing the right numbers here. And the reason is that each time I call compute coin, even though I actually update amount, this is a different amount variable than the one up here. So when I call compute coin with amount that has 86 in it, I make a copy of it. This is pass by copy. I make a copy of it. I happen to call it amount. That's fine. I get the right value, but then I change my copy of amount to be the 11 remainder of that 25 division. When I come back into main, amount is still 86 because I only changed the copy. I do a mod of 10, I get 8. And that's why I see these values coming up all wrong. Now, if I make one small change, if I do ampersand here, now when I pass in compute coin with that particular amount, I'm going to actually make the change. I'm going to actually make the change to the amount in my main program. I'm getting this compiler error, by the way, because I have to also change the prototype. If I forget to change the prototype, just to give you an idea of why we're losing this, we're getting compiler error because compute coin actually does not have a real definition. Compute coin, the prototype, is now not the same as this. Pass by reference is part of the function signature, and that's important to remember. So we need to change it in both places. So if we run this now, because when we pass amount, we're not actually using a separate copy. We're actually really still using that same amount. Now we'll get the numbers we expect. If I type in 0.86, we get 3/4, 1 dime, no nickels, and a penny. All right, and that's correct. I want to point out and just make sure there's no confusion. I could have called this X. The fact that that was named amount and so was this was not the issue. The pass by reference says when I call this with amount, I'm actually passing in, this is not really a distinct copy, x is simply an alias of amount, and when I change x, I'm really changing amount. And if that sounds confusing, you're not alone. Right? Pass by reference is inherently confusing. When we need to use it, and why do we need to use it here? Well, because compute coin is returning a value, but it's also updating, so really it's producing two changes that we need to be able to use when we call compute. Amount should change, and I should get a value for quarters. I'm in a situation where my function does two different things, and when I'm in that situation, there's nothing I can do other than use pass by reference.